Go on.
Okay, basically, 1/n,
Yeah.
is that only for a circle? So if it was like a linear type thing, it would be 1 rather than 1/n, like the distance between the two locations.
Well, I think that's all explained in the question. I think that falls under my previous comment of people treating the question as something that it wasn't. I shouldn't say any more than that.
Oh no, it's just theory.
Oh,
No, seriously though, like what I'm talking about is
No, I understood your question, and that was what?
because when you find the what's it called? The triangle, yeah. Like when you find the distance, is for the circle it was half n, so for that one it wouldn't be 1/n, would it?
Be
The
1/2.
distance. Like for the linear type thing. So that's just theory. I'm just asking theory right here.
Well, the area of a triangle is half base times height, so you've just got to work out what the lengths are.
Yeah, but then
And then the lengths are given in the question. So
Oh.
I shouldn't say any more
Thank
because.
you. I understood.
Okay.
Yeah.
Oh, speaking of transportation costs, for the circular model,
Yeah.
to find the transportation cost, because it's not a right angle, if we just do like base times height, not the half, that's what I observed.
Yeah. Well. Yeah. It's slightly funny, isn't it? So
Yeah.
you're thinking that people are living on a circle, and this isn't a straight line. Okay. But you can. So it's a 3D. It's a 3D thing. Have someone got a piece of scrap paper they can give me?
Yeah.
Thank you. Yeah, I'll illustrate this.
Just read it.
Okay, so here are our transportation costs in the hoteling model on a nice straight line. And all we have in the salad model is, the line that it's based on is curved,
Yeah.
but it doesn't really make any difference to the area. The area of the triangle is still the same, it's just that you kind of rotated everything.
Then how come in our example we didn't times it by half? Because we didn't treat it as a normal situation.
Really?
Let me just
Show me in the lecture slides. It's possible there's a mistake in the lecture slides,
we did it by this calculation. I don't see that we times it by half.
Because we're two triangles, maybe?
Oh, but we're trying to find for one, or is it for two triangles?
Yeah, I think we were doing it for
Oh,
That's alright.
okay,
Sorry.
so between any two firms, half of them are going this way, half of them are going this way. So there is some transportation costs on this side and transportation costs on that side. So you've got two triangles. So yeah. Anything else on the test? Or?
So as a general rule of thumb, the length of the circle is always 1/n, and for the line it's always like not 1/n.
It's always what it says in the question. I could write a question where I say, imagine there's a, obviously I'm not going to do this on Friday, but maybe I'll do it on the final exam. Imagine that there's a circle of length 200 and there are 5 firms around it, then of circumference 200, then what's the distance between those firms?
Okay.
Yeah. Okay, so you just have to read the question, I think. Nothing else anyone wants to ask on the test?
So the models aren't going to change, right?
No, I'm trustworthy. You can,
Thank you.
It's really his incentive for us to succeed. So
yeah, well, I want you to do well, and it's good that it's good that you have a base of marks before you go into the final exam. I think it takes some stress out from you, doesn't it? So what normally happens when I give the questions in advance is that the distribution becomes, I give slightly harder questions, okay? People like you who vaguely do a bit of work, you'll do fine, okay? So most of the maths gets shifted that way. Some people don't even look at the mock test, and because the question's harder, they do terribly. So it just kind of spreads the distribution a bit. So most people do very well, but you get a few people that do terribly. But to be honest, if I give a test in advance and you don't look at it, I don't feel so bad about those people not doing so well. So I think it's good for the median student. Okay, so it should be good for all of you. Is that horribly unfair?
No. Oh. That could be unfair. You've given everyone a test.
Have I done what?
You've given everybody a test. So
Yeah.
It's not unfair.
Okay, so should we go through some of the exercises I set, or do you not even care about exercises at this point?
Depends what the exercise is.
I can comfortably say I didn't do any.
Did anyone look at any exercises?
Depends which one.
Okay, so you did. You did?
I did many exercises, but I'm not sure it was the ones you set.
Okay, well, if you had struggled with anything,
Not that I can remember.
okay. So I suppose going through product differentiation ones is more useful. So I put the complete set that I set you was 7.6 questions 2, 3, and 4. Okay, well, why don't I get you to have a go at these on the board, if you haven't had a go at them before. So you can work collaboratively on the board or something, and I'll point. Okay, so 7.6 question 2. Anyone have a look at this one? So we've got a linear, we've got a hoteling model. Okay, but there's only one restaurant, okay, so rather than being 2 restaurants, there's only one. So then this question might help you with answering question 1, in fact. So it's not useless. This restaurant here has 0 marginal cost, and there's a $1 transportation cost. Okay, so consumers have a utility of U is B, so some constant B minus A, which is their location. Okay, so this is 0, this is 1. Thinking about consumer located at the point A from the question, and this restaurant is charging a price P. Okay, so they get some constant, they get some value from consuming the good. Okay, so they've got a choice. They can either consume the good and get the value B minus their cost of walking minus the price they pay, or they can consume nothing at all. Okay, so eat otherwise. They've got a choice. And we're told that naught is less than B is less than 1. And so the question says, find the number of consumers eating at this restaurant, calculate monopoly restaurant's price and profit levels. So does someone want to have a go?
Sorry, could you say what's $1 again? You said something
Oh,
about
the
$1.
transportation cost was $1 per unit of distance. Okay, that's why it's just why it's their location. So we're thinking about a consumer locating at point A. So it's like a hoteling model, but there's only a restaurant on one side. So is there going to be an indifferent consumer in this setup, and what are they going to be indifferent between?
Eating or not eating.
Eating or not eating.
Practically, they can't be indifferent.
Pardon?
Practically, they can't be indifferent
Why?
because they gotta eat.
I guess they have some outside option of,
Yeah.
I don't know, eating some leaves in their garden. Okay, so they have a choice about whether or not, they get 0 utility if they don't eat. They get, rather than minus infinity, if they were going to die. So it's not an absolute necessity.
So B is the value.
B is just some constant, yeah. Yeah, it's their value for consuming the good, exactly. Yeah, you're right.
Okay. So what are you asking again, sorry?
So, well, what price should this monopoly set, and what profits will they make? Someone want to go?
I'll just do it, but I'll embarrass myself.
No, go on. Thank you.
Can I ask you the question as well before I do it?
Listen to you.
Yeah, so the setup for question 1 was a bit like this, right? I told you consumers' values from consuming certain
Can I
goods.
just change the whole thing? I'll just do it my way if that's okay.
Okay.
I don't like
Okay, let's call it V then. Fine.
Yeah.
Yeah, put V there. Okay. We just renamed B to V. So what are you going to do first? What do you always do first in these questions?
The price. Yeah. Oh.
Well, what do you do before finding? So normally the first thing we do is. So we want to work out where the indifferent consumer is, right? Because the indifferent consumer is going to tell us the demand that this firm is facing. Once you know where the indifferent consumer is, everyone to the left of the indifferent consumer is going to buy from the firm, and everyone else isn't going to buy.
Stop me if I'm doing it wrong. Transportation cost.
So everything's already, so that's for transportation costs, the A term. So A is their location. So this is given their transportation cost. So this is their value, the utility. If they buy the good, if they don't buy the good, they get that. So what's the indifference condition just going to say?
B minus P equals 0.
Yeah, exactly. So this thing is equal to this thing for the indifferent consumer.
Oh, so that's what we're doing.
So where's the indifferent consumer going to be located?
At wait.
Should we arrange for A?
Yeah, so A is the location here. Okay. So if we just add A to both sides, you get V minus P is equal to A.
Okay.
Does that make sense?
I'm trying to. So do you remember that sign? I don't know if I'm thinking of the wrong thing. This sign. Is
Theta, yeah.
Could you say that's comparable to A or not?
Yeah, yeah, so theta was a location along the line, so A is to
A, would you say A is sort of comparable to theta then?
Yeah, yeah,
Okay.
it's a location, just like theta was.
Okay,
Okay.
alright.
So that's where you think about things.
Yeah, so we've got... I'll just do that for the love of Jesus Christ.
Okay.
Okay, so we've got that. So now you're going to find P of, like say you just found A times theta,
Mm-hmm.
and that goes into
Mm-hmm.
that's A as well, right?
Mm-hmm. Yeah, it's only one term. Yeah.
So, do you have any marginal costs?
No, no, marginal cost is zero. So this thing is equal to zero. Yeah, so that's found the price. And then the question goes on to ask you to find profits. Well, that's just a matter of substituting that into the...
Oh wait, no. Did I just do
Yeah,
it?
no, that's right. So, yeah.
Oh yeah, okay. So that's the location of the different consumer, yeah?
Yeah, okay. So A was V minus P. Okay, P was V over 2, so A is also V over 2. So you've got price times V over 2. So price times V over 2 is this is the profits, what you found.
Oh yeah, it's a profit, yeah.
Yeah.
Wait, is it the... Oh yeah,
Yeah.
sorry.
And you can substitute in input for P as well. So it's going to be you know what P is.
So this is EA.
Yeah, that's where you started from. So substituting in the PA here.
Mm-hmm. So you get V on 2.
Yeah, exactly. So V squared over that.
Should I find this stupid right?
You don't need a second divide. So this is just the same as PA times V over 2, right? So it's just going to be V squared over 4. I know it's hard with everyone looking at you. This is my excuse for making slips.
Wait, so you're dividing all of this by 2, right?
Yeah, that's fine.
So you get the...
So
I don't even know. This is like that's like GCSE and I can't do it.
So you got V times V, and you can put that 2 on the bottom. Okay, so you get V times V and 2 times 2. So it's V squared over 4. No, not V over 4. Sorry.
Just do it. I can't.
Okay. Sorry. You're getting confused between addition. Huh? So this is just the same. You can write this as well.
I just can't think when it's like that.
You can write it as like this if you like. Does that make it clearer?
Yeah.
So you've got V over 2 times V over 2.
Yeah.
So this is just the same as V squared over 4.
Okay.
So the question said we had to assume 0 is less than V is less than 1. So why did that matter? We haven't used it when we solved this. What would have changed if that wasn't true?
not have been able to set the, we wouldn't have been able to find the indifferent consumer, would we, if v is greater than 1?
Okay, so the indifferent consumer was at v minus p.
I have a question.
Go on. Have we made a mistake somewhere?
After, okay, PA equals V over 2, why did you substitute V over 2 as A up and above?
Because A.
Yeah, you just put
A
V over 2 equals.
is v minus p,
Yeah, yeah.
okay, which is v minus
V over
v
2.
over 2, which is v over 2.
Alright.
Sorry,
Oh,
what
we got
was your-
substituted there, okay.
what was your question about V again, like the inequality?
Why does v have to be less than 1, and how do things change if v is bigger than 1?
Okay.
So, well, okay, so let's look at the case where v is equal to 1. Maybe we can find out what's going on in that case. So where v is equal to 1, the price is going to be equal to a half. The indifferent consumer is at 1 minus a half. So the different consumer is at a half. So it's not immediate. So certainly, if v was 2, you'd have problems. Okay, because then the...
Would it not be, like, if V was greater than 1, it's not indifferent anymore, because it would be out of consumer's reach, or is that not?
No, so v being bigger than 1 is just going to move the indifferent consumer past the middle point. Okay, and what I expect is going on, I haven't looked at the answers, but so remember that we found these profits of v squared over 4, yeah? The monopolist always has the option of setting a price at which everyone would buy. So, you know, if you like, the demand curve here is a bit funny because I'm not sure. Let's have a look. So suppose I set a price at which everyone would buy. Well, what price would everyone buy?
Oh, it's indifferent.
Yeah, so the indifferent consumer has to be over there.
0.
So
Because A would be 1.
do you mean 0? You got the v term as well.
Well, if price would have to be 0.
Price is 0. So okay, so v is bigger than 1.
Oh, right.
Okay. Suppose v is bigger than 1. Okay, then you can sell to everyone with a positive price, right? Okay, so if you set a price of p is v minus 1, everyone will buy. And if you set that price, what are your profits? Well, so you sell. You know, you can never sell to more than 1. Okay, so this is why this formula might not apply if the price is very low. Okay, so if they choose this low price, well, they sell, the price is v minus 1, the quantity they sell is just 1. Okay, so their profits are equal to v minus 1 as well. With this other thing, they had profits of v squared. Yeah, sorry. So if they do what's normally the optimum, they get profits of v squared over 4. If they price this way, they get profits of v minus 1. Okay, so when v is 1, this is a quarter, and when v is 1, this is 0. Does this work? But when v is 2, this is 4 divided by 4, so that's 1. And that's 1 as well. I don't
Is
know
it just
the
because
prices.
it's sort of talking about range of preferences rather than something else. So it's just saying that V is between 0 and 1 simply because you can't have a preference greater than 1 of something.
Yeah.
So if to use your spicy example from the last lecture, you can't like it, then
No. So V is just the value you get from consuming the good.
Isn't like, you know, the range is 0 to 1?
Yeah.
Isn't the low end 0? Isn't like the low quality, and then the 1 would be the high quality? So it's a bit impossible if a consumer was to consume a lot more than high quality, because that's the like highest valuation, the market value is the product or the firm.
No, so V is nothing to do with their location. V is just their value from consuming the good in the first place. So, you know, you can value consuming a good at 100. The only thing I wonder is whether we've made a little slip somewhere, because it would make a lot more sense if the question had said V is less than 2. You know, then I could understand what was going on. It's possible there's a typo in the book.
mathematically I don't think we've made a mistake.
No, I don't think we have. Yeah, I think there's a typo in the book. He does have a load of typos listed on his website. So maybe,
Oh, do you know that one? I
Yeah.
think it's V squared divided by 2, not by 4. I've
You-
just done it, and it seems
It's definitely by 4.
Is it?
Yeah.
Jesus Christ.
So the price was V over 2, and so this was price times A, okay? So price was V over 2, A was equal to V over 2, so we had V over 2 times V over 2, which is V squared over 4. It's easy to make these slips.
So just another quick question.
Yeah, go on.
In terms
Oh,
of
crap, yeah, that's what
methods of finding the different consumer,
Yeah.
two.
Kill me.
In terms of utility, and the other is in terms of price and transportation costs.
Yeah, so when you're doing it in terms of price and transportation costs, you know, implicitly you're doing the same thing in terms of utility. So, you know, if you think about the original, think about the original hoteling model. I don't suppose anyone has Odshire's official answers in their bag, do they? Printed out? I'm sure that question was wrong. Slightly unfortunate. Okay, so here's the original hoteling model. You've got these ice cream sellers either end. Okay, 0 to 1. And what we normally do is we say, well, okay, here's our guide X. If he buys from A, he pays a price PA and he walks a distance X, and that costs him TX, say, and we say that that has to be equal to PB minus T.
Wouldn't it be plus?
Yeah. Okay. Okay, so he pays the price PA, and he also pays this transportation cost. Well, this is the cost he's paying. Okay, you can think of these ice cream stands as both giving him the same value. They're both selling the same good. Okay, so in terms of values, well, he gets a value V from consuming the ice cream, and then he pays PA and he pays the transport cost. Or if he goes the other way, he gets the value V from consuming the ice cream. He pays PA and the transport cost. Okay, so these two things are the same. You know, the V's drop out and then you flip the signs, and one is the same as the other. So there's only really this is the way you should always think about it. Okay, but you know they're choosing whichever one gives them the highest value. It just happens that when both things are selling the same good and they don't have any choice but to consume the good, then the two things are the same.
Oh, so one's in terms of utility, the other in terms of value.
No, one's in terms of cost, the other's in terms of value.
Well, yeah.
Let me see if I can get to Oshai's website. It's really annoying with that typo. Okay. The next question.
So Tx is A. Technically.
Is what?
Because in our first example we had V
Yeah,
A, so
yeah.
A is Tx.
Yeah, A was like the Tx term. So A was location and T was equal to 1. Errata. Okay, what edition do I have? It's terrible with the typos in these books. Let's just look at the official answers. So question 3 we went through last week, didn't we? Question 4 is not worth doing because it's 2 things that we did in the lectures. 12.9, question 1. So there's a question on vertical differentiation. So, did we do this last week as well? We did, didn't we? Okay, so what about an advertising question? So 11.7, question 1 and 2. Good. Okay, does someone want to have a go at one of these advertising questions? That was a rhetorical question. So for the first one, let's go through them in order. Okay, so congratulations, you've been appointed to become CEO of Ugly Inc., the sole producer of facial oil skin life extender. First assignment is to determine the advertising budget for a year. Marketing department provides you with 3 important pieces of information. The company is expected to sell $10 million worth of a product. Okay, let's call that Q. Or PQ, I suppose it's revenue, is 10 million. Okay. It is estimated that a 1% increase in the advertising budget would increase quantity sold by 0.5%. Okay, so PQ were no advertising. Okay, so A up by 1% means Q up by 0.05%. Okay.
Is it 0.5% or?
It says 0.05. No?
Sorry, I misheard you.
It is also estimated that a 1% increase in the product's price would reduce quantity sold by 0.2%. Okay, so price up by 1% implies. So this is telling you the elasticities, basically, isn't it? Q down by 0.2%. And the question is, how much money would you allocate for advertising next year? Okay, so if you got something like this, you'd use these formulas we had from the simple advertising under monopoly thing. So we had this Dorfman-Steiner condition, right? But RA over PQ is equal to epsilon A over epsilon P. So yeah, so we can just apply this straight away, can't we? So we know the revenue. We know the advertising elasticity. So what's the advertising elasticity? What's this epsilon A?
0.05.
Yeah, exactly. So this is just the definition of an elasticity, right? The elasticity is the percent change in one thing you get when you make a percent change to the other. Okay, so advertising up by 1% increases demand by 0.05. Okay, so this is going to be 0.05. And on the bottom we have price elasticity of demand of minus 0.2%. Okay, so just taking the absolute value at 0.2. So this one was very easy. Okay, so we know approximately what your total revenue is. Okay, so your total advertising expenditure RA should be approximately equal to 0.05 over 0.2 times 10 million. So yeah, it's quite a practical way of approaching these problems, I suppose. If you're an actual company, it's quite plausible that you know that, and you know that. So if you're an actual company, you could do this calculation quite easily. You don't really have to do any maths. So let's forget about the rest. So the next question says that in Fortune City there are two fortune sellers, Alpha and Beta. Okay, each fortune seller charges a fixed regulated fee of $10 per visit.
What? That seems an awful lot.
In New York, it's plausible for the fortune telling. That's $10. Okay, so I guess it's the price. Price is $10. So the price is fixed, and these two fortune sellers are just going to compete by choosing how much advertising to use. So AI is going to be the advertising expenditure of fortune seller I. Okay, so we've got A alpha and A beta. Okay, that's the advertising expenditure of firm alpha. That's the advertising expenditure of firm beta. And the number of clients visiting each teller per unit of time is denoted by Ni. Okay, so we have N alpha and N beta. Okay, and in particular, N alpha is given by 6 minus 3 A beta over A alpha, and N beta is given by 6 minus 3 A. So you're not told where these demand functions come from, but there's some. Okay, so there's some demand for the good that's increasing the amount of advertising that they perform, the relative amount. So in order to get people to buy your good, you have to perform more advertising than your rival. What does this look a lot like? Doesn't it? It looks quite like a corner setup, doesn't it? Don't you think? So in fact, the way you're going to solve it is going to be a lot like a corner setup. And profits are apparently given by 10 Ni minus A. Oh yeah, because your price is 10. Okay, so the profits for firm I are going to be this price of 10 times the quantity they sell, which is Ni, minus their expenditure on advertising, which is AI. Does someone want to have a go at solving that game? surprised you agree. We're like. Okay,
Like I
meanwhile.
had a choice.
Pardon?
Like I had a choice.
You had some choice. Okay, I'm gonna.
So I guess I rearrange to find what A alpha is in respect to that, and then put it into, oh yeah.
No, so you know what profits is. You can substitute this into profits, and that gives you profits in terms of A.
Alright.
Okay, and then firm alpha is gonna choose A alpha to maximise their profits, and same with firm beta.
Uh, 12.9.
This one.
That one. I don't know what that one is. Where was the first one in the book?
It was 4.7, I think. No, 7.6. Yeah, 7.6, question 2. Yeah, okay, so it always helps to multiply out the brackets. So you know what profits are for firm A. So now firm A wants to choose advertising in order to maximise those profits. So it looks, once you get to this point, it looks a lot like a core no problem. Right?
It's like differentiate with respect to.
Yeah. So this is just, this is just a constant effectively. So it's just like taking the derivative of 1 over A alpha. Right?
Yeah, but
So derivative of 1 over x.
minus.
Yeah, exactly. So the minus 1 term came from this bit, and then we had, well, there was a minus sign to start with. So minus minus, that's going to be a plus there. So that was a minus sign, and then you got a minus sign from differentiating. So you're taking two minuses. Okay, so that's a plus. So you don't need one there now.
That's right.
Yeah. So this thing was equal to that thing, so you took that to the other side, so 30 a beta, okay, and then do the square root. Yeah. Yep. So that's the reaction function of firm A in terms of firm B. Firm B, well, everything's completely symmetric, isn't it? So you can just guess, you kind of know straight away, but for firm B you can have the other thing, but back to front. Yeah, exactly. So then it's just a matter of solving those two equations. You can maybe just see what the solution is. You know, so think about substituting this one in there, okay, you get...
Oh, right,
yeah. Maybe
It's not as easy as this.
Okay, I found the official answer to the first question we did. I read the question wrong to start with. The monopolist was supposed to be in the middle of the interval, not at one side.
Ah.
So that's why their conditions were different to the ones we got. Okay, so we were correct in what we did, but we just answered the wrong question. So there's a lesson there, but you should read the question better. Sorry.
I have no idea how to solve that.
Okay, so, well, this is, you know, so you can think of this as, so you can always, when you've got a square root, you can always split it in two, okay? So the first thing you can do is, you treat this as square root 30 times, what's it down if you want, square root 30 a alpha. Okay, so we've just taken that bit and that bit separately. Okay, and then we can do the same thing here as well. Okay, so this is going to be square root 30 times square root of 30 times square root of a alpha. Okay, but you know, this is just taking the square root is like raising to the power of a half. Taking the square root twice is just raising to the power of a quarter. Okay, so this is 30 to the power of a half plus a quarter, so 30 to the power of 3/4, which is just some number, times a alpha to the power of a quarter. So you've got a alpha on the left-hand side as well. Okay, so divide everything by a alpha to the power of a quarter, so then you have a alpha to the power of 3/4 is 30 to the power of 3/4. Okay, so a alpha is equal to 30. And let's just check that makes sense. Well, if you plug 30 back in here, you get 30 is equal to square root of 30 times 30 is just 30. 30 times 30 square root is just 30. Okay, so this is going to be the solution. There's also another solution with everything equal to 0. You know, 30 times 0 is equal to 0. Square root of 0 is 0. So there are potentially two solutions here. And you'd have to check profits to find out which one was highest. The question in the book walked you through lots of steps before you got to that point, so I expect to make it easier. And I guess you should run if you're going to get to your next lecture. Hope you're not stressed about tomorrow. You're good. Should be quite easy. Pardon? Yeah, but do have a go at the first question. You know, people who come to this class are normally the better students, so if you're not having a go at this first question, you know who will.